Yeah, let's go on with the next example. Now this polynomial function has a degree of 4, so we have 5 coefficients. Now this is C4, this is C3, C2, C1, C0. You see all coefficients are positive and not 0, so we can at first say condition 1 is okay. So we have to start with the Hurwitz determinant. This is Hn. Hn is 4, so the H4 determinant with 4 is a 4 times 4 determinant, 4 rows, 4 columns. So starting with not the highest one, the second highest one, C3 is 2, then C1 is again 2, then there is no 1, 0, and we need 4 places, so there is another 0. The second row starts with C4 is 1, then followed by the over next, C3 is 3, over next is 2, and then there is no 1, 0 cell. Third row is first row, 1 cell shift right, so we get copy of the first row, and the fourth row is a copy of the third row, 1 place shift right. Note that here the bottom right element is always, in any case, the C0. Now we need this information later for some discussions. This is 8, C0 is 8, here C0 is 2. So in any case, the bottom right coefficient here, the bottom right cell contains C0. It doesn't matter. Of course, we can now calculate H4, but stop. A good hint, start with H2. Why? Because if H2 is violating the condition of Hurwitz, we can stop. And then there is no need to calculate H3 or H4. So, of course, we start with the simple conditions, and then, if this is true, go to the next one, which may be a little bit more complicated or time-consuming. If this is true, then we start with the calculation of the last element. So I think start with H2 to save time, yeah? To save sometimes time. If this condition is true, of course, then we have, of course, to calculate H3 and H4. So a good tip is first calculate H2. H2 is this determinant is 2, 2, 1, 3, which is 2 times 3 minus 2 times 1 is 6 minus 2, which is 4. Of course, this is larger 0, so okay. So next we have to do is H3. H3 is the subdeterminant with following elements or cells 1, 3, 2, 0, 2, 2, and we have to calculate this, so we can decide. Here are 2 zeros, not in the same row or column, so either I can develop for this or for that cell. I recommend to do this because you will see just at once this is 0 times anything is 0 minus this coefficient times the determinant 2, 2, 0, 2 plus determinant 2 times, yeah. And now you see, if I develop for this column, I need H2, and H2 is already calculated. So if you have complicated numbers, of course, then you can easily say, okay, this is H2. So we have -2 times 2 times 2 minus 2 times 0 is negative 2 times 4 plus 2 times 4. Yeah, h2 was 4. And here you see this is 0. And that is not okay. So we can say the system is unstable. Or a border case, but border case is also not a good control loop. Yeah? So if we have a closed loop system with this border case 0, then of course we cannot use it. So we can say unstable or indifferent. Yeah? If we check the poles, we have the following result. So I show you a program where we can check the poles. It's my tool program, WinDF Sharp has a 0 calculation program. So I think we should start this and type in the coefficients here. So I stop for starting. Yeah, you have only to know that the pole 0 calculation is behind this UFK load button. Here you can define numerator and denominator time constants, coefficients, and then calculate the poles. So I shift this to this position and open this box and shift this in a region where we can see what happens. So the numerator degree is 0 and the denominator degree is 4, and the denominator coefficients starting with C0 is now 2, 3, 2, 2, and 1. So if we type this in, we click to factorize, we get the information that the poles here, I should make them a little bit larger, poles are 0 and -1 plus 1, -1 minus 1. That is a conjugate complex pole combination where the real part is negative, so these both are okay. The imaginary part here is the same, but here you see the program throws out an e10 to the power of -17. This is 0. Independent of this sign, 0 is not allowed. So we can say result the poles are written in our node tab are p infinity 1 2 is 0 plus and minus j1, and p infinity 3 4 is Nein, back to the program. Das war schon wieder falsch. Oh man, wo ist das Programm? Da. -1 plus -1. Ja, genau. -1 plus and minus j1. So, yeah, this is not okay. The 0 is not okay. That means if there is a 0, one of the determinants also are 0, so we are in the indifferent case, and that is not allowed. Okay, next example. Yeah, let's do the job with case B here in this exercise 4.1. Case B should be copied into my paper, and then we solve it with the Hurwitz criterion. Again, we have an n is 4 type, so we can just and see first criterion is C4 is 1, C3 is 2, 3.2 is 2, 3.1 is 10, and 3.0 is 25. So condition 1, all coefficients are positive, and not 0 is true, is okay. Condition 2 now is executed. H4 is a 4 times 4 determinant, with starting with a 2 here, then 10, 0, 0, 1. You see, if you one time has understood the law of filling the determinant, it is rather easy to fill this determinant. 0, 1, 2, 25. Note again, bottom right cell gets C0. We start with H2, as I mentioned before. Do the start with the most simple step. H2 is 2, 10, 1, 2. This is 2 times 2 minus 10 times 1, and you see this is 4 minus 10. This is negative. Negative, so negative. That means we can stop here. Stop here. System is unstable. You see, there is no need to calculate H3, no need to calculate H4, because H2 violates the Hurwitz condition, and that means if one condition is violated, the system is unstable. We can stop here. The poles are given with the following result. If I use again my program, the resulting poles are, I write it down. Yeah, in my program I have just exchanged the coefficients here. You can compare it. If I factorize these, then you see the resulting poles is positive 1, minus 2, 2, minus 2, 1, 1. So you see here this program, of course, looks for the signs here and detects instability. So we write down the result 2 plus and minus J1 and P with this P infinite 1, 2, 3, 4 is 1 plus minus J2, and this was man, my brain is just negative 2. So this is okay, and this is violating the pole criteria for negative real parts. So these are not okay, unstable. So of course the result of Hurwitz and poles must be the same. Let's go with now the third example. Let's go with an N5 example. So the E here is row E or task E has a fifth order polynomial function. So I go with this. Look for D. Example D is all coefficients are negative. This is an example where you can extract the minus sign and then all coefficients are positive, and you have to go to the Hurwitz criterion. Okay, let's go with E. I copy this in my on my board and then continue. Yeah, we have now an N is 5 element example. So we have to fill H5, and we have 5 rows, 5 column determinant, starting with 6 in the top row. Then we go to 20, 4, 0, 0, starting with 1, 15, 14, 0, 0, 0, 6, 24, 0, 0, 1, 15, 14, 0. And yeah, now here we see the 5th line. Of course, it's then the 3rd line. 1 row shift right, 1 cell shift right. This is 4. And again, you see here we have the C sub O element in the bottom right place. And again, I want to start with the most simple top left subdeterminant is 6, 20, 1, 15. So the coefficients leads to this value 6 times 15 is 90 minus 20 is 70. This is okay. If this is okay, I have to continue investigation. The H3 determinant can be written as 6, 24, 1, 15, 14, 0, 6, 20. Of course, now either this or that element I have to do. I develop to the third row. So I have 0 times this determinant, I leave it out, minus 6 times subdeterminant 6, 1, 4, 14, plus 20 times H2, and H2 is known as 70. That's the advantage to develop for this row. If I have developed for this column, of course, then H2 was not needed, and I have to calculate the determinant here. It was a new value. So this is a trick to save seconds in calculation. So I have to, what is this? Sorry for the value. Is negative 6 times 14, 60, 84, minus 4 is 80, plus 20 times 70 gives the value. With a calculator I have got 920. That's also okay. So I now have to go to the calculation of H4. As it is necessary to do this, because now all other conditions are still true. So H4 is 6, 24, 0, 1, 15, 14, 0, 0, 6, 24, 0, 1, 15, 14. So I see this is a development which is good. Of course, here this could be done, but I select this column to do the job of development rule, which is plus minus plus minus plus minus minus 4 times subdeterminant 6, 24, 1, 15, 14, and last row is 0, 1, 15, plus 14 times H3. H3 is still calculated here to 920, so this has been calculated. If we do this, we see the result of this determinant. I have calculated out of video gets the following value. So the result of this determinant is 970, and the final statement is H4 is negative 4 times 970 plus 14 times 920 without result. You see 14 times this minus 4 times this cannot be negative, so this is not necessary to calculate the final number. We can see exactly this is larger 0, and note that H5 is nothing else than C0 times H4. If C0 is positive, this must be true, and H4 is positive, we have calculated here, then of course H5 is also larger than 0. There is no other way. We can say this system is stable. in any case of n, we can say Hn is always must be C0 times Hn minus 1. So we can say if this is positive, this also is positive, then of course this is positive. So it is never necessary to calculate Hn, because you can stop with Hn minus 1, because automatically if this is positive, Hn also must be positive, otherwise you have stopped check with condition 1. Yeah. In any case of n, Hn it is not necessary to test it. Not necessary to calc Hn. So with this result, just we should check the poles of this polynomial function. I use my tool program and get the following result. As in my tool program, I typed in the coefficients in the given order. Here you can compare the numbers. I click on factorize, and then you see the poles. I have all real parts. System says stable, independent of imaginary part. We have a -1 for real part. Here a real pole, a conjugate complex pole. This is 0, so this is 3 real poles and 1 conjugate complex pole. So this is the result. So just I write this down in my paper. Check. Poles are P infinity 1 is -1. The second pole is also -1. The third and fourth pole is -1 plus and minus j1, and the fifth pole is -2. And again, cause coincidence of the statements of both pole criteria.